So I'm going to be talking about .NET 5. It's a pretty big topic, so I had to kind of pick and choose what I was going to present. So I apologize if you're one of the few in the crowd that is attending this meetup in order to learn about Windows ARM64 support, or if you want to know about click once being backed by popular demand. Not really going to talk about those things, but those things are cool. I just don't have enough time in this presentation to actually cover those topics. Won't be covering Xamarin Forms, even though Xamarin Forms did receive some pretty cool updates. I'm going to focus mainly on Blazor, some of the cloud native investments, and Project Tye, which is another very interesting experimental developer tool set that Microsoft's working on. So who am I? My name is Stewart Southwell. I'm a consultant with Improving. I've been working for a long-ass time in web application development. In terms of .NET 5, I've been using .NET since .NET 1.1. So the basic agenda is kind of what I've already mentioned. Also, C#9, I will be doing a quick demo to go over a subset of some of the new C# features. And we'll kind of wrap up with, doing a quick shout out at some of the other things that have come about with .NET 5. And we'll begin by doing a quick overview of .NET 5, starting with a brief history of .NET. So .NET originally was standardized back in December 2001. So there was a runtime specification that came about called the CLI, or Common Language Infrastructure. And then in 2002, .NET Framework got introduced. Because of the specification, we ended up getting a lot of different runtime implementations, like Mono, which was for Linux-based OSs, Silverlight, who I think we all anticipated overthrowing Adobe Flash, but that never came to fruition. So if you've worked on Silverlight, kind of sucks to be you. Then we also had .NET Compact and micro frameworks as well. And then in 2016, we had .NET Core, which was the successor to .NET Framework. The primary goal of .NET Core was to modernize the environment and to also be a cross-platform. And we ended up getting a formal specification called .NET Standard as well. And this is where a lot of people get confused when they're coming to .NET initially, is you almost need a decoder ring to kind of figure out which of these things you end up having to, or end up needing to target. And so the motivation behind .NET Standard was to establish greater uniformity in the .NET ecosystem. And then we had .NET 5, which was kind of like .NET Standard, in the sense that it was also trying to achieve greater uniformity, but it went about it in a different way. And we'll kind of go over that in a minute. So there can only be one .NET. So because we've had such great fracturing in the platform, we're bringing everything back to the mothership. And so we have multiple base class libraries, and these things are all being consolidated into a one .NET, essentially. So the single SDK, one base class library, and a unified tool chain. So .NET 5 has nearly identical platform support matrix as .NET Core 3.1. If you're using .NET Core 3.1 on a supported operating system, you should be able to adopt .NET 5 on the same operating system version. The most significant addition for .NET 5 is Windows ARM64. And that's something that your bosses might like, because if I recall, if you're spinning up a ARM64 VM in AWS, I think it's about 20% cheaper than the Intel counterparts. So it's a big win in terms of cost savings generally. Now, as part of .NET 5 and 6, .NET, of course, as we just talked about, is being unified into a single product experience. But it also enables you to pick just the parts of the platform that you want to use. So if you want to target mobile and not WebAssembly, you don't need to download the WebAssembly tools or vice versa. And the same applies with ASP.NET Core and WPF. You also have a much easier way to acquire all the .NET tools and build in runtime packs that you need from the command line. In addition, there will be a package manager experience for .NET Platform components, and that will be useful for many scenarios. For example, a quick construction of a development environment or a CI/CD pipeline will probably be the biggest beneficiaries of the package manager experience that they're introducing. And the first step towards kind of accomplishing this vision was consolidating the .NET repos. So having one repo for the runtime and the libraries for .NET is was a precondition for delivering the same product everywhere. It also helps with making broad changes that affect the runtime and the libraries, where there were previously repo boundaries that you had to deal with. And some people were, from what I remember, some people were originally worried that a large repo would be harder to manage, but so far that hasn't really proven to be the case. .NET Framework is not going away. So if you think that .NET Framework is going to be retired, it's still there. It will remain a supported Microsoft product and will continue to be supported with each new version of Windows. And Microsoft announced last year that they stopped adding new features to .NET Framework, and they finished adding the .NET Framework APIs to .NET Core. Because .NET 5 is essentially just the evolution of .NET Core. And so now is actually probably a great time if you're considering moving your .NET Framework apps to .NET Core. So for .NET Framework Server developers, you need to adopt ASP.NET Core to use .NET 5. And if you're using web forms, which I doubt anybody attending this meeting is using web forms unless they're forced to. But if you are using web forms, then Blazor will probably provide you with a similar developer experience, but with a more efficient and modern implementation. If you're using WCF still, WCF is not going to be officially maintained, but there is community projects which will continue the work of WCF. So if you do want to continue using WCF, you should go check out those projects. And so when you're deciding whether or not you need to target .NET 5, it really comes down to, if you have existing code that's targeting .NET Standard, then probably don't want to do anything unless you really need the language enhancements or the additional runtime or platform features that you get with .NET 5. If you're doing new code and you're creating an application component, for example, then you probably want to target .NET 5. But if you're building a reusable library, and as you know, when you're building a reusable library, you have to decide, what is the reach of this library? How many runtimes are we going to have to be able to run this library on? And so the more that you have to reach, the greater compatibility requirements you have. And so you may, if, for example, if you need to support .NET Framework, you're going to want to target .NET Standard 2.0 because .NET Standard 2.0 is the latest version of .NET Standard that supports .NET Framework. If you're building a reusable library and you don't need to worry about some of those older platforms, then you do want to probably target .NET 5. You could target .NET Standard 2.1, but .NET 5 implements .NET Standard 2.1, so it's really pointless to target .NET Standard 2.1 over .NET 5. So that should greatly simplify the choices you have because you're reducing the need for .NET Standard except for a couple of specific workload types. The release schedule going forward. So this is what Microsoft's been missing out on for a while now. They didn't really have a predictable release schedule, which for a lot of businesses is a no-no because you have to be able to properly prepare for an upcoming release. And so Microsoft adopted a release cadence where they're going to do a major release every year in November. And every even numbered release will be an LTS release, so long-term support. And a long-term support release is good for 3 years. And the current release, which is the odd-numbered releases, are going to be supported for 3 months following the even-numbered LTS release. So I don't really like doing slides, so I did prepare some demos. So let's go ahead and do a quick C# demo. So for this demo, I'm going to do it in .NET Interactive running within a Jupyter notebook. So if you've never used .NET Interactive, I would definitely recommend checking it out. You do need VS Code Insiders to use it. But once you get it set up, you can easily spin up create a new notebook or open an existing notebook. And so the features that I'm going to cover is a very small subset. I did include a link to the documentation page at the end of the slide deck if you want to go look at all the other ones, but I don't really have time to go over all of them, so we're just going to go over a few. So the first one I'm going to go over is the top-level programs. Let me get rid of that guy. So if you spin up a new app, let's say a console app, generally speaking, in statically typed programming environments, there's a lot of ceremony and cruft involved, which can be a barrier of entry to any new programmers coming in. And so, you have classes, you have main methods for your entry points. You may have namespaces surrounding it. And so there's a lot of ceremony involved that you have to figure out when you come into a new environment. Sometimes you just want to express yourself. And so they made it so that, for example, you don't really have to have some of these things. Now, this doesn't mean that, this is something globally available to everything in your application because it's scoped within the file, but you can express yourself this way and run it and get the result. And this would have honestly worked anyway with .NET Interactive, but if you did spin up a console application and you were not targeting .NET 5 or using C#9, you would not be able to do this. So that all looks good. I'm going to paste this in here. I really like the object initializer syntax, but what I don't like is the fact that anybody can come in behind me and, change my last name. I don't really like the fact that somebody can do that.
Hey, Stewart, real quick, can you zoom in on the content?
Oh, yeah, sure.
Thanks.
Let's see. I mean, I could zoom in a little bit, I guess, with. So control mouse wheel is not working. Anybody know off the top of their head?
Control plus should do it.
What was that?
Control plus should do it.
I think in the view options, if you
Oh, there you go. Control plus. Sweet.
Perfect. Thanks.
Yeah, control mouse wheel did not do what I wanted, but control plus did. So, all right, can everybody see? If you can't see, let me know and I can zoom in a little bit more.
That's great.
So you may say that, we can, get rid of the setters, but problem is we can't continue using that object initializer syntax when we do that. And so they came up with kind of a middle ground approach where you just add an init. And you still cannot, or you cannot change the last name anymore because we got rid of that setter, that public setter, but we have the init, so we can initialize it. So that's all well and good. So we're able to get kind of immutability, which is a pretty big trend in programming nowadays. It makes it easier for you to reason about your programs. And it's something we see a lot on front ends with single page application frameworks, to where you cannot modify the existing state. You have to clone it. And so you preserve your prior state and then you clone it and you can augment that with additional state if you want to. So they're coming out with the exact same thing in C#, as C# slowly kind of evolves its way into JavaScript. So they introduced the record type. This is something they've been thinking about for a while. It's something that I believe Kotlin already has. And once you enter the world of records, you pretty much have to stay in the world of records. So records are reference types, but with value type semantics. And we'll go over that. And these are kind of immutable or guaranteed to be immutable. And we can combine this with like a with expression. So if we want to create our other person with and change the last name, you can do that. And everything's good. These are completely different objects, and we can prove that with if we do actually let's do a copy that down. So equality with record types are going to do a shallow comparison. So it's only going to compare the properties within the object when it does the equals checks. And so in this case, they're both false. But if I wanted to, for example, change back let's change this to be run that. So now we have these being equal because the properties match each other. And reference equals is false because these are not the same reference. They're copies of each other, and with object initialization as kind of the second stage occurring to modify what that new object is. The other thing I really like is we have really good toString implementations with record types. So you could do and get rid of this display person entirely. So it has a really nice readable toString implementation. And another, astute observer might point out, okay, you have a person type here, but what if you have, what if you statically type it and then create a new student? And let's say we set the GPA on that student. I don't know how students nowadays get above 4.0 GPAs. Back when I went to school, you could only get a 4.0. So if we go write this out again, so it's actually, it complies with whatever that runtime type is when it does these checks. So what else can we do? Well, this is kind of annoying that, when you create a record type and you have to, create all these properties, that can get a little verbose. And you can also have constructors with record types because these are emitted as classes underneath the hood. But there is a shorthand syntax you can use. So you could specify, this is a string first name, string last name. And then this will generate those properties underneath the hood. And same thing with the student. So and anything downstream, you gotta make sure you pass in and add the double GPA. So because we added this constructor now, of course it's required. So you would have to kind of switch how you're creating this. And because records support construction, they do support destructuring as well as part of this. So we could deconstruct rather into a couple variables using this tuple syntax. So see if I have that right. Oh, even if I don't have it right, I have this figured out with this. Oh, missing a semicolon. Got, I don't know how many people on this call pair programming. Nobody told me I was missing a semicolon.
Do you want us to shout at you what to type?
What was that?
Do you want us to shout at you what to type?
That would have been helpful. So there's a lot of other great features in C# 9, but I do have a lot of other things that I want to show in limited time frame with which to do it. I would definitely suggest at least checking out some of the C# 9 pattern enhancements. Patterns came out with C# 7, was improved again in C# 8, and improved yet again in C# 9. So definitely go check out the documentation if you want to find some of these other C# 9 changes that have come about. So that's it for the C#. Let me switch back to my slide deck, and I will be briefly going over Blazor and some of the enhancements with Blazor. So Blazor is kind of the lit thing nowadays. I definitely suggest trying it out if you haven't. So there were some pretty significant enhancements with Blazor. Now uses .NET 5 core framework libraries. So they were, I think, the first project type to actually be brought over and start taking advantage of some of the new stuff. Originally, it was using Mono. It's a lot faster than the previous release. It supports server-side pre-rendering and lazy loading dependencies. And so it's slowly morphing its way into an actual competitive product to some of the other single-page application client-side only frameworks out there. So it's adding a lot of these features that we tend to take for granted nowadays. It offers component virtualization. They did add a lot of new component controls, such as virtualized scrolling. So if you have a list of items, you only need to show a subset of that list, and as you scroll, it will go back to the server to fetch the next update. It also supports CSS and JavaScript isolation. This is something that will localize your styles or your JavaScript to the particular component that you're working with. And then, as I mentioned, there's a lot of new components. And you also have the large ecosystem of third-party and OSS controls and tools like Infragistics, DevExpress, Telerik. They all have pretty big control suites for Blazor. So let's take a brief look at Blazor. And I actually already have the project open and created to save a bit of time. And one of the first things you'll notice when you spin up a new Blazor project from the template is it now targets .NET 5. Previously, it would target .NET Standard 2.1. And if we run this real fast, so we have our Blazor app here. One of the major kind of goals with .NET 5 is because you have all these APIs suddenly available at your fingertips under the .NET 5 umbrella, there's certain contexts with which you don't want to be able to use some of those APIs. And so they really put a lot of emphasis on Roslyn analyzers. And so you'll have a bunch of analyzers enabled by default. So for example, if you wanted to do like let me actually do it in this one. If you wanted to do like a console.read line, well, browsers have no idea what a console.read line is. And so you will be notified that, console.readline is unsupported on browser. And so there's a lot of these things that you'll get quick feedback on, at compile time, as opposed to waiting at runtime and finding out that, a particular feature is not supported by the platform. So if you want to do, as I mentioned in the slide that we went over a second ago, if you want to do like a CSS isolation, it's super simple to do. If you go into, let's do it for the counter component. So if we go to pages, if you add a new CSS file, and by convention, we are calling it the exact same thing as the component. And let's overwrite the H1 tag and give it a different font color. We save that. And all right, let's rerun that. I don't know if that worked. We have counter razor. H1. All right, let's stop this for a second. Oh, maybe if I went to the actual page counter, we would have seen it. So we see that the color has changed there. So what if we want to deploy this somewhere? So there is an option in preview if you want to publish this to a GitHub action. So if you go to preview features, you'll see GitHub actions, support, and publish. And I've already kind of set this up, but if you were to go and create a new publish profile, you have all these different targets. So if you want to target Azure, go to like Azure App Service. And I've already set up the app service instance. You can create a new instance from within this dialog box. And it now targets .NET 5 by default. So you don't need to go in and switch it over. They must have made that change in the last couple of weeks, because when I tried this a couple of weeks ago, I had to actually go into the portal and change it back to, or change it over to .NET 5. So if you go to next, you have this option to publish automatically using a GitHub action, and it generates a workflow file. And so the file looks like this, basically. So if you're used to building pipelines, this is kind of what you end up doing a lot of. And you have a secret here. And so this actually pulls from, let me bring over GitHub. So you can go to your Azure portal and download the publish profile. You take that publish profile, and you do have to actually change the publish URL to be the kudu URL. So there is kind of a small bug, but once you do that, you can paste that in. And then when you actually commit your code, you'll now have your action that will deploy to that target environment. So if we go and we check in the change we just made with the style, let's stop debugging that. So once you commit that and push it up to GitHub, it automatically triggers the workflow. So while that job is running, I'm going to open up another instance of Visual Studio. And I'm going to show some of the Web API changes that I found to be pretty interesting. And you have this new option here called Enable Open API Support. Oops. So Microsoft partnered with the Swashbuckle team in order to kind of better integrate the swashbuckle tooling with Visual Studio. And so in a new web API project, by default, you have these package references already kind of set up for you. And additionally, they've set up the launch settings file to automatically open up the Swagger page when you start a new project. And it's taking a sweet time. So if we run this project, you have the Swagger doc, and you can do pretty much anything that you want to do with it. So if you want to, add new, or if you want to run any of these operations from within the Swagger page, you can do that pretty easily. Another option, which I really like, is the HTTP REPL tool, where they made a lot of really nice updates to that. And I will show you how to use that and integrate it with Visual Studio in just a second. So now we have our Blazor website up in Azure. And if we click on counter, you have our new color. And if you look at how this works, so they generate an attribute which they target with the attribute selector. So that's how they localize it to the particular component that the style sheet is associated with. And I don't have time to show it, but if you did enable pre-rendering, you would not be able to see that loading text at all, because it would just be almost instantaneous. So if you go and do the global install for the HTTP REPL, once you do that, you can go set it up in here, where you see I have the option here to change what I'm targeting. And so if you were setting it up, you would essentially, you would go add a browse with, there you go. You'd go add it here, and you'd just specify, where that application is located. But since I've already done that and I changed the target to it, all I need to do is run it with F5, and it will open up a terminal for you. And you can just run normal directory commands. So ls will list your operations. You can cd into cd. I don't know if you guys can see this because the text is kind of small.
I think you just got a misspelling.
Thank you. Did I again have a misspelling? Oh, I'm already in there. That's why. So once you're in there, you can.
I think you need to go back down to the root.
Dear Lord. Oh, yeah, that's right. Thank you, Kelly.
I got you.
So you can go fetch the data in that way. If you did have a post operation, you could also do a post, and which I haven't included one here, but I could. If you do a post, it would open up whatever text editor you have associated with HTTP REPL. And once you make a change and save it and then X out of the program, it will automatically post those results back. And it creates a template in your editor of choice that mimics what you see in the Swagger page when you want to mock a post request for that operation. So it already has everything kind of stubbed out, and you just change the values to what you want to change them to.
G'day, Mark here. How comprehensive is the interface here? So can you do headers and things like that?
I think you can. I'm not sure off the top of my head how to do that. I'd have to look at the documentation.
Yeah, we do a lot of stuff in Postman, and you can set different attributes and properties and headers. So
yeah, I'm pretty sure it gives you that control. You can use HTTP REPL directly instead of going through like Visual Studio or VS Code, and you'd have access to the kind of full, which I can't remember what I have on the path off the top of my head. So
yeah, sure, cool, thanks.
No problem. So let me switch back to my slide deck really fast because I want to go over Project Tye. So Project Tye has been in the works for a bit of time now. It's still kind of in alpha. It may be released in .NET 6. I don't think we have an official word on that yet. But one of the challenges one of the challenges with developing a microservices type application is being able to run it locally and not have all these things kind of installed on your own machine, and have that kind of smooth end-to-end experience for developing, testing, deploying, having service discovery, external dependencies with Redis or SQL Server, etc. And also giving you, in this case, a dashboard for like metrics, logging and debugging. And there's a lot of mental load involved when it comes to microservices oriented projects in general, especially if you're deploying to an environment like a Kubernetes environment where you need to have Docker files for your various applications. You need to have Kubernetes manifest files, etc. And if you're doing Helm charts, you need to know the particular flavor that you need for Helm charts. And there's a lot of kind of disparate pieces that you need to go and learn. And so Project Tye's primary goal, I think, was to simplify a lot of that and make it a bit easier for people to get up and running with the microservices project. And so we'll take a look at that. And, Tye automatically Dockerizes employees to AKS, and it also works with other implementations as well. So let me really fast X out of that. Okay, so to get started, we kind of need a project to work with, don't we? And we'll create that. But first, because it can take a bit of time, I just want to really quickly create a AKS cluster in Azure, because that's where we want to end up deploying to. So we're going to just use, which I think I'm still logged in. Let me see. So let's create a new cluster. And I've already created ahead of time the resource group. .NET 5, I think it's .NET 5, XYZ. And we need to give our cluster a name. .NET 5 microservices. And because I'm cheap, let's specify a node count of 1. And we want to generate our SSH keys, because that's how our Kubernetes context in our local environment is going to communicate with the remote AKS environment. So we'll let that get started and finish doing the work it needs to do. And let's jump ahead and go create our microservices projects. So for the first project, let's create a backend project. Actually, let's create our front-end project first. So we're just going to create a new Razor project for that. And right off the bat, we can run that project using Tye. And so we have our dashboard running at localhost 8000. And so our dashboard is basically composed of our bindings. So this is what a service is actually listening on, how many replicas it has, and you can view the logs associated with it. And you can also view kind of the metrics involved. So these are performance counters that it's picking up. And so the dashboard is basically just the UI that displays all your services, et cetera. And so we can't really do much with, or we don't really have a microservices project with just one project. So let's go create another project. So let's shut this down. Control C, thank you. New, let's create a web API project, and we'll just call it backend. And give me 1 second. I want to move these into separate folder. Let's copy our front end. Right, let's add a new solution. And we will add our projects to the solution. And if we run this now, it's going to pick up the solution file automatically. And now we have two services that it picks up. We don't really have our front-end project talking to the back-end yet, so we'll do that. Let me really quickly double check, see if so we have our AKS cluster created. So we want to configure our local Kubernetes context to target our AKS cluster, because that's what Project Tye will make use of by default. So to do that, we need to get our credentials. And the name of our cluster, I think, was .NET 5 microservices. We'll overwrite this. And so you can kind of verify that that was successful just by, going to your Docker, and you can look at Kubernetes. You see your context is currently targeting .NET 5 microservices. That's good. You can also look, see the pods you have out there. Which I don't have any out there yet because I haven't deployed, but we'll get there. So now that we have the project created, let's go open the solution. And we can use Visual Studio or VS Code. I'm going to use VS Code. And let's create a weather forecast CS file in our front-end project. And to save typing, I've already prepared some scripts, or at least I think I did. And we'll add the weather client CS file. And this is what will be used to actually communicate with the backend service. That's what is going to be configured with the HTTP client. So nothing really special in any of these things. You guys have probably done this all before in .NET Core 3.1. So there's nothing that's like new in this file, for example. And now we need to add a reference to Microsoft Tye configuration. So let's do that. So we're going to add a .NET add front end, CS proj. And we need to register the backend with the front end. And so this is where the service registry piece comes in. So inside of configure services, we add our weather client and we set the base address. And we're using our friendly identifier for our backend. And it's very important when doing microservices to employ service registries, because the scheduler or the cluster resource manager will move things around out from underneath you sometimes. And so you do want a registry to kind of have a centralized kind of system of record for your services and where they're located. So after we do that, we also need to add a forecast property to the index page model. Which I have here. And we need to change the onGet method to take the weather client to call the backend service and store the result in the forecast property. So if I go to my little snippets area, that's not what I wanted. So we have this new attribute saying that we're getting this from our service registry, or we're getting this yeah, whatever that text says exactly. So it's calling a get weather async. We're setting the forecast property. And lastly, we have to change the index view to actually consume it. Let me undo that for a second. So if we run the project now, and we go to our project, if we click on the front end, now this is loading from the backend service. And let's see if we can actually see that with the logs for the backend. think we need to add something if we want to pick up the request. And these get changed randomly, these values do. So if I refresh it, we'll get new values. Tye also has an optional configuration schema if you want to customize settings. So it contains all your projects and external dependencies. If you have an existing solution, Tye will automatically populate this with all your current projects. So to initialize this, we actually, let's see. We're going to add 2 instances running. So if we want to initialize the YAML file, we just do Tye init. And in our VS Code, oh, wrong VS Code. So it's pretty easy to add external dependencies if you want to add external dependencies to this. So we could add a Redis. So if we go to the backend project and we go into our controller, I'm going to add a couple using statements at the top of this file. And then we have to update our get method. Rid of that. And so we're taking our distributed cache. We're looking up by the key. And if we don't have anything there, then we generate a new one and we write it back to the cache. And we set the expiration timer to 5 seconds. So we should be able to see this when it works, because when we refresh the page repeatedly, we will see the same value. And then 5 seconds later, we should see some new values show up. So first, to get the backend fully working, we need to add a package reference to Stack Exchange Redis. So let's do that. And go into configure services. At the very end. So now we have Redis set up in our app. But we still need to add to the Tye YAML file. And this is where Docker images come into play. So make sure you have Docker installed if you're trying to run Tye on your computer. So we've added the 2 external services. The Redis CLI service is used to watch the data that's being sent to and retrieved from Redis. So if we go back and we try to run this now, we should see those 2 additional services show up. So we have this configured to use Redis now. So if we actually open up, well, let me see if I saved everything. Maybe that would help. Control S. That bites us every time. X out of that. So values stay the same for 5 seconds until it gets expunged from the Redis cache. And so now, what if we want to deploy this? Well, Tye will not deploy the Redis configuration, so we need to deploy that first. Let's X out of this, and we'll do another kube controller command called apply, and I have a URL to Redis YAML file that I'm going to use. So now, now that we have that out of the way, deploying this is super simple. It's just Tye deploy. I'm going to do I for interactive. Into the container registry. If you're using Docker Hub, this will just be your username. You may need to execute the Docker login command before you actually run this so that you're authenticated. So our connection string is just going to be Redis and whatever port it's listening on. It's 6379. Yay, we have that deployed. And so basically a Tye deploy does a few different things. It creates a Docker image for each project in your application, pushes each Docker image to the container registry, and generates a Kubernetes deployment and service manifest for each project. And it applies the generated deployment and service manifest to your current Kubernetes context. So you should now see 3 pods after deploying. So let's go and take a look. Yeah, we have our 3 pods. We can visit the front end application, but we need to port forward because if we look at the services right now, these are all private IPs, so we can't really, just go paste that in the browser and be able to access it. So we need to set up a local port forwarding rule with our local Kubernetes context. And so we can do that with port forward, service front end, and whatever port mapping you want to use. So we're going to do 5080. So now if we go and we open up, so if we go to localhost 5000, we're communicating directly with our AKS cluster. Our local Kubernetes context is basically using an SSH tunnel to communicate with it. And so when we did that generate SSH keys, it was setting up the security for making and establishing this connection. And if we wanted to simplify things further in the YAML file, we could also add a registry to the YAML file. I'm not going to bother because it's not really needed for this demo. What if we want to make this accessible to anybody, not just me from my local machine? We need to add an ingress controller so that that would basically sit in front of your cluster and all traffic would route through that and would go to whatever map you've set up. So to do that, we're going to take an ingress rule and we're going to paste it into our Tye YAML file. And so when we use whatever the public URL is at the root path, we're going to route to our front end service. So our front end service will receive traffic. So after we add that rule, it's super simple again. Just do Tye deploy into the container registry. So you don't have to use Nginx. You can use other ingress controller types as well. This is just used by default. And while I was doing that, it could take a second for it to get everything situated. Yay, we have our ingress controller. It could take a bit of time before the address actually shows up there. So if we go and we look at all our services across all our namespaces, we have our public IP that we can use. So this is something that, any of you watching this now could open up your browser and navigate to. But I suggest you don't, because I don't want to, drive up my compute costs. And when you're done, tearing things down is, again, super easy. So it's Tye undeploy. And it would just start spinning down all the services that you just created. So that's kind of, in a nutshell, what Microsoft's working on, and they still have a lot they want to do with this project. So I don't think they've officially said that they're targeting .NET 6. I think they want to make .NET 6, but who knows? So let me switch back to the slide deck, and there's only a few more slides, I promise. I was going to briefly talk about the performance. So I'm not going to really go in depth on the performance side because there's just a lot there. I did provide some links if you want to do kind of further reading on it. Or if you go to techempower.com, you can look at a lot of the community benchmarks. But the performance in .NET 5 is pretty darn insane. Just looking at gRPC performance, the only platform that is better than .NET 5 currently is Rust. So it's better than Go even, which I was surprised at, and also better than C++. And so this result is mostly because of the HB2 implementation, which gRPC uses. That's the biggest performance impactor on gRPC performance is your HB2 implementation. And there's a lot of other .NET 5 performance as well. So a lot of core improvements in the garbage collection process, which if you do want to read more about this, I recommend looking at Stephen Taub's blog, because he blogs with about, I think, around 170 different performance enhancers that got added to .NET 5. And he also includes pull requests for where these improvements were added to the source code, if you're interested in that stuff.
Could you pop a link to that blog in the chat, perhaps?
Oh, yeah, sure. Let me see if I can bring it up. So here is a link to one of his posts, and I think he has a link at the very bottom to a series of posts which he has made on this topic. Let me find where is the chat. I hate how Zoom kind of hides the various panels sometimes.
Should be right across the bottom.
Yeah, I see it.
Cool, thanks.
Yep. So some of the other improvements, which we didn't really talk about, was a single file deployment and executable. .NET Core 3.1 also had single file deployments, but the mechanism they used was completely different. .NET Core 3.1 used extraction mechanism, so it would extract the binary contents in the package to a temporary folder before it actually executed. So they definitely did some changing of the internal architecture with .NET 5. And so you do get some pretty big performance improvements with the single file deployment in .NET 5. App trimming, that was, again, one of the goals with .NET 5. and also .NET 6 is to kind of eliminate the cruft in the final deployment package. So it's going to get rid of and excise things that are not needed. So assemblies that are being linked that are not needed, those will not get packaged in. Click once has been brought back due to popular demand. Some of the notable performance improvements. Garbage collection, of course, was probably the biggest area of improvement in terms of the overall performance of the platform. Had some pretty good performance increase with system.text.json as well. And we didn't really get to cover like Xamarin Forms and some of those improvements. Xamarin Forms is probably going to fully adopt .NET 5 or fully adopt the unified .NET core framework with .NET 6. And there's some other things as well that were originally supposed to be included in .NET 5 that did not make it in. Part of that is due to COVID. For example, there's different platform-specific target framework monikers for .NET 5. So if you want to bring in some Windows-specific platform features, you can do net 50-Windows in your CS proj for your TFM, and it would expose that particular API for you. And so a couple that were not included in .NET 5 was the Android and iOS target framework monikers. So we should see those in .NET 6, but not quite there. We also did not have a chance to talk about .NET MAUI. So .NET MAUI is going to be kind of the universal UI platform that is being worked on currently. And so that's kind of the what Xamarin is going to evolve into. But right now it's just, if you're using Xamarin, you're just using Xamarin Forms. So those are some things you want to keep an eye out for going forward. And I provided some reference links. I'm going to flesh out this slide with some additional links as well. So it's not quite finished, but it should be done this evening. So I can send those to Mark to upload. And that's it. Does anybody have any questions or comments or anything else they want to add?
Mark, again, you mentioned when we look at the previous session before Tye, we were looking at the integration with Swagger, Swashbuckler, I think you called it. Mm-hmm. Does that track API changes so that they then appear as Swagger endpoints, or is it just the initial Swagger setup?
It's just the initial Swagger setup. They may have plans for that going forward. I need to check what those communications are. Because if they did give you an option where, or at least give you a toggle option where you can either toggle it from, the Visual Studio project template, create new project setup, or add it to the CLI to where you can say, hey, enable versioning for me and have it automatically configure, the Swagger doc to have versioning enabled and hopefully scaffold something out with kind of an example of, this is the opinionated versioning scheme that we recommend going forward that complies with, OpenAPI.
Hmm.
I do hope they add that part to it.
Because we keep writing APIs with a bunch of endpoints, and every time you add a new endpoint to your API, you then got to go over to Swagger. And, you've got to line those details up. It'd be great if that was automated in some way.
Oh, for sure. Let me actually write that down. I can pass it along to the team and see if that's on the roadmap form.
Cool. And the other question was in Tye. So were you deploying to the cloud at that point. I thought everything was happening local on your machine. But when you said hit this link, no, don't hit it because you don't want to bump your costs.
Well, I started out running locally, and so it's going to run with, the local Kubernetes context on my machine. And so I'm actually running I'm essentially running a local Kubernetes cluster, right? I can't remember. I think it may use Minikube underneath the hood as your local Kubernetes cluster. But when you do want to deploy it, I changed the context of my Kubernetes, of my local Kubernetes to target my remote. So if we, go back to my Docker configuration, you have this Kubernetes here where you have your context, and see how it has .NET 5 microservices.
That was your local, yeah?
Which can't seem to get out of my way there.
Yeah, cool. All right.
So initially, when you spin up a new project and you just want to run it locally, you just do a Tye run, and it's going to run with your local Kubernetes that you have. So when you install Docker, it automatically kind of sets that up for you. And your local Kubernetes is configured in, so if you're on a Mac or Linux machine, it's at your user root or your user home directory, and same with on a Windows machine. So you have, see if I can find it. It's kube here, and you have your config file. And so when I went and set up the AKS cluster, and then I invoked the git credentials, it modified this config file, and it configured it to actually set the credentials for my local Kubernetes context to, by default, be pointing to my AKS cluster. But if I do a Tye run, that's still gonna run my local Kubernetes. It's only when I want to target the remote where I need to set up that port forwarding rule so that I can route traffic through the SSH tunnel that gets established to my remote AKS cluster. And so I have that specific port mapping that I had set up, if you recall, the port 5000. So if I go to localhost 5000, that 5000 is actually being routed through that SSH tunnel because it's listening on port 5000. And it's being routed to port 80 on the remote side.
Right.
But if I just did a Tye run, it's going to use whatever the generated port is for running my local Kubernetes cluster. And so I'm still running my local if I just do a basic Tye run.
Right. Yeah. Thanks.
Yep.
Does anyone else have any questions for Stewart? Well, if not, thank you, Stewart. That was very enlightening. That was some cool stuff.
Yeah, I was a little worried about the time because there was a lot of stuff, but I think I left. I don't know when these meetups typically end. I can't remember, but I think we're towards the end of that. So I will pass the baton back to you, Mark. You want to do any roundup?
Thanks. Yeah, we have a soft close at 7, but we have till 7:30. 4 super interesting topics that we need to continue checking out. This definitely falls in that category. So, so as soon as Stewart gets me his slide deck, I will post it up to the Meetup so everybody can download it and check it out. And looks like there's some very useful links in there. So be sure to check that out. And again, thank you all for joining us tonight. We certainly appreciate you coming out. And we hope to see you next month for Azure Logic Apps. So thank you again, Stewart, and we will see you all in the new year. Thanks.
Thank you. Same to you.
Yeah, thank you guys.
Bye.
Have a great night.
Great job.
You too.